time. I think this is 12A part 1. Okay? Now if you're doing the reciprocal, okay, you want to think about the important features and then you connect the dots. Okay? Think about the important features and then connect the dots. So the first most important pair of features actually is that being that this is a reciprocal, where the original function is 0, what does that mean for the reciprocal function? You'll get asymptotes, won't you? Okay, so let's, I'll do it in this color. So there's your first vertical asymptote at going through the origin. Okay? And your second one, which is going through x equals 2. Okay? So I should probably put that on there. X equals 2, x equals 0. Okay, now you look at some other useful features here, right? You have a stationary point, and you know exactly where the stationary point is. Now, we were pretty sloppy in translating that onto your graph. Now, have a look. It's at 1, 2. So what's the reciprocal of 2? Not a rhetorical question. It's a half, isn't it? Wow, the variety of places where you put this new stationary point. Sometimes it was close to a half, sometimes it was nowhere near it. Very few people actually labeled it. If they label, you should label. Okay, make sense? So, there's the first thing I'm going to put on there. At 1.5. If it's not your question, that's fine, but it'll be for some of you. That's why I'm picking it out. Right, now what happens, since we started on this inside section, what happens to the left and right of this stationary point? Okay. Well, if you're approaching 0 for both of these, right, that's the denominator approaching 0. What's happening to the reciprocal function? If its denominator is approaching 0, what's happening to the whole thing? It's going to skyrocket, isn't it? So it'll do this. Okay, so apart from the choppy position of the stationary point, like some of you even put your stationary point up here at the original, where the original stationary point was, because you didn't realize that that was a 2, you've got to be careful, okay? Now let's have a look at the left and the right. Over on the left here, okay, we're approaching an asymptote, aren't we? Now, what asymptote are we approaching? It's, they give us the equation, right? This is, my scale's really off actually, sorry about that. It should be -1, so that should be much lower down, but I'm running out of space, okay? Now if you're approaching -1, what's the reciprocal of -1? It's -1 as well, right? So when you're taking the reciprocal function and you take the limit as x approaches -infinity, that's where you're going. Why am I below the axis the whole time? How can I know? Like, how do I know it's not approaching from the top? When you have a look at what you're taking the reciprocal of, all of these guys are negative, right? So all of their reciprocals will also be negative. Okay. All right, last piece. Some of you saw, oh, I have an asymptote over here, so that's where I'm approaching. And you drew it approaching the same asymptote over here, but it's not. And you need to think carefully, because it's not a symmetrical graph. So in some senses, we shouldn't expect it to do the same thing on both sides. Okay. Over here, it's dropping like a rock to -infinity. So what's its reciprocal doing? What's it approaching? It's 0, right? So that's why it blows through, and you have to draw in a new asymptote, right? Whoops. There you go. Okay? That's what that looked like. Shh. The 2 marks I was looking for, this section up here, this parabola-looking part, being correct and it having its location of a stationary point, right? And the second mark was for both of these branches underneath the axis. You needed to nail both of them. If one of them was wrong, then you lost that mark, even if the other side was correct. Okay? Now, let's have a look at this one. Okay? There were 2 marks. Come on, you're pretty smart. Where do you think the 2 marks went? Think about it. Shape is a good thing to judge, but I'm kind of judging shape all the way through, right? What's the difference between this and the original graph? There are 2 differences, aren't there? What are the 2 differences? There's a shift and a stretch, right? A scale issue. So this is vertical and this is horizontal. So I was looking for each, okay? And a lot of people will do one but not the other. Okay? So for instance, if I moved over, right, the roots are not going to be 0 and 2 anymore. What will they be? Instead of 0 and 2, they'll both be shifted 1 unit to the left. So I'll be at 1 and -1. Okay? You're going to get the same kind of shape happening, but that's not the only change. Since it's vertically different, right? My max used to be at 2. What will my max be at now? It'll be at 4. So up your scale goes, right? A lot of you forgot to put that up there, right? The max used to be at 1, but I'm shifted 1 unit over to the left. So where should the max be now? Right on the axis. Right there. Okay. The last important piece with the scale is that, see how you've got your horizontal asymptote here at -1. Well, that's going to go down just like this goes up. Okay. So -2. Okay. So that's what I'm going to approach. Now you've got all your pieces, and you can draw the thing. Let's give it a go. That's doing that. This is going to come down. I missed, but you get the idea. And I'm approaching this new asymptote. Okay? Now,